Welcome to another video. In today's video we will be solving delete the middle node of a linked list problem from the Leetcode. In this problem we will be given head of a linked list and we need to remove the middle node from the linked list and return the head of the linked list. One thing to note here is that if a linked list has odd number of nodes, that is if the length of the linked list is odd, then we can easily identify the middle node because we can use two pointers such as slow and fast, and based on some condition we can identify the middle node and we can remove it. Similarly, for even numbered linked list we have to consider it as zero indexed array. So if it has four nodes, then we have to remove the second node because 4 by 2 becomes 2. In the problem statement itself they have mentioned we have to remove n by 2th node. So if it has 4 nodes, then we have to remove the node which has index 2. Since it is 0 indexed, this node will have index 0, this second node will have index 1, and the third node will have index 2. So 4 by 2, this node we have to remove. Let's go through some examples to understand how can we find middle of the linked list for even and odd scenario. So let's say we have odd numbered linked list, odd numbered in the sense linked list of odd length. Let's take two pointers, slow and fast. Each time when we move the pointers we are going to move slow by one position and fast by another 2 positions. So after the first iterations, what is going to happen? Slow pointer will move by 1 position and fast pointer will move by 2 positions. So here we can say that in odd numbered, if linked list length is odd, then fast dot next becomes null first. Fast dot next becomes null. So let's consider another scenario, and then we have to remove the slow node. Remove slow because slow will be pointing to the middle in case of odd scenario. Let's consider a linked list with even number of nodes. Let's say we start with 2 pointers slow and fast pointing to the head of the linked list. After the first iteration, what is going to happen? Slow pointer will move here, fast pointer will move here. So for even let's say if linked list has even number of nodes, then fast dot next becomes null. And then according to the problem statement we have to remove this node. So we have to remove slow dot next. So this is the only thing we have to understand in order to solve this problem. Let's implement the same technique using C++. So we wanted to delete the middle node of the linked list, but one more thing we have to consider here is what happens if linked list has only one node. So in that case, according to the problem statement, we have to remove the node which has index 0, because if the length is 1, then n by 2 becomes 0 and 0th index refers to first node. So that is one more scenario that we have to consider while writing the code. So if linked list is empty, if head is null, then we don't have to do anything, we can just return the null. And one more base case is if linked list has only one node. In that case also we have to return null, because this condition comes from the problem statement itself. And then we can apply this technique that we used to explain. So let's declare 2 pointers. One is slow, it will be pointing to head of the linked list, and another pointer, it will also point to the head of the linked list. And we need one more pointer to store previous node of the slow pointer, because sometimes we have to remove the node which is pointed by the slow. So at that time we should store, it is better to have this node, and then we can start going through the linked list. While slow and fast are not null, first thing that we are going to check here is, let's go through our diagram first. In case of odd, fast.next becomes null. So if fast.next is null, then we know that it is a odd linked list. Linked list has odd number of nodes. So we can keep a boolean here, is odd length, and we can set it to false initially. If this condition is met, then we know that linked list has odd number of nodes. Then we are going to do is odd length. We are going to set this to true, and we are going to break out of this while loop. We have to remove the slow node. So that thing we can take later. Otherwise we also have to check whether fast.next is null. If this condition is satisfied, then we can simply break. Otherwise what we can do is, we can store the slow pointer in previous slow, and then we can move the slow pointer by one position, and then fast pointer by 2 positions. Once we come out of this while loop, then we can check if is odd length is true. If this is the case, according to our explanation, we have to remove the slow node, because that will be pointing to middle of the linked list. So what we are going to do is, previous slow dot next will be equal to slow dot next, and if that is not the case, what we should remove? If it is not odd length, we have to remove slow dot next. So what we are going to do is, slow dot next will be equal to slow dot next dot next. Since we are accessing various pointers here, before accessing fields inside a particular pointer, we have to check whether they are null or not. Previous slow and slow are not null, then only we are going to perform this operation. Otherwise our program is going to crash. Now here also we have to check whether pointers are not null before accessing fields inside them. And then what we can do is, we can just return head of the linked list. Let's run this program and check whether it passes the initial test case or not. Yes, as you can see here, this is passing the initial test cases. Let's submit the solution and check whether it passes all the test cases or not. Yes, this solution is passing all the test cases. If you are interested in learning more about other data structures and algorithm related problems, please check out other videos from my channel. Thanks for watching this video.